The objective of this lesson is to multiply a whole number by a fraction greater than 1. As students reason about fraction multiplication, there are two key considerations: what is being iterated or partitioned, and what is referenced as 1. For example, if asked to determine how many eggs are in 1½ dozen, the expression 1 1/2 times 12 can be used to represent the problem. The students should ask themselves the following key questions. I am finding how many of what? 1 1/2 of 12. 12 what? 12 eggs. And what is being referenced as 1? 1 egg. If 12 refers to 12 eggs, then 1 refers to 1 egg. Let's begin with the following problem. Camille used a 2-liter pitcher to fill a fish tank. It took 4 1/2 pitchers to fill the tank. How many liters were needed to fill the tank? This equation can be used to represent the problem. 4 1/2 pitchers times 2 liters equals n liters. Let's model this problem by using pattern blocks. A red trapezoid can be used to represent each full pitcher, and a half-size brown trapezoid can be used to represent the pitcher that is 1/2 full. To represent this problem, I would need 4 red trapezoids and 1 brown trapezoid to signify the 4 1/2 pitchers. To aid understanding, the following key questions should be answered. I am finding what of what? Or what is being iterated 4 1/2 times? 4 1/2 of 2. 2 what? Liters. What is referenced as 1? 1 liter. By adding the totals together, we get the answer of 9 liters. This problem can be easily multiplied by using the distributive property. Looking at the model, the equation could be written as 4 plus 1/2 times 2 liters. Students would multiply 2 liters by 4 and then add that answer to 2 liters times 1/2. The equation would be 4 times 2 liters plus 1/2 times 2 liters equals 9 liters. The product refers to 9 liters and not 9 pitchers. 4 1/2 pitchers equals 9 liters. Here is another way to model the problem. The 4 blue rectangles represent the 4 pitchers. 1/2 of the first rectangle is outlined in red. We can see that each rectangle is divided into 2 sections representing the 2 liters in each pitcher. The last pitcher is represented by 2 yellow rectangles, which represent the 2 1/2 liters. Let's try one last problem. The Corythosaurus dinosaur was 2 2/3 times as tall as a 6-foot tall man. How tall was the Corythosaurus? This equation can be used to represent the problem. 2 2/3 times 6 equals n. To clarify understanding, ask the following questions. I am finding what of what? 2 2/3 of 6. 6 what? 6 feet. What is referenced as 1? A foot that is the unit of measure for the man in the comparison. Let's model this problem by using 2 hexagons, representing 2 6-foot tall men. 2/3 of 6 is 4, so we can represent the 2/3 of 6 with 4 triangles. This diagram shows that 2 times 6 feet plus 4 feet equals 16 feet. Another way to model this problem would be to draw 3 rectangles and partition each rectangle into 6 sections. Each section in the rectangle represents 1 foot. In the last rectangle, each of the 1-foot sections is divided into thirds. 2/3 of each of the sections are shaded. The first 2 rectangles represent 2 times 6 feet equals 12 feet. When the shaded 1/3 sections are added together in the last rectangle, it would equal 4 feet. This equation could be written 2 times 6 plus 2/3 times 6 equals 16. The objective for this lesson was to multiply a whole number by a fraction greater than 1. We met this objective by writing equations, drawing models, and asking key clarifying questions to make sense of the problems.